All right, today we're going to take a look at the notes for section 10.5, day 2, and we're going to use the line of best fit to continue to make predictions. This is on page 24 of your packet. All right, it says the table below shows the length in inches of baby alligators born in September, and they're going to count September as what we call month 0, because right when the alligator is born, it has a length, but it doesn't really have an age. He's 0 years old. So he's 22 inches, in this case, at 0 months old. So the first question says, use the table to create a scatter plot. All right, a scatter plot is just a bunch of points. So all we have to do is we have to go to our graph, and we've got to sketch those points. So my first point is 0, 22. So that's going to be right there toward the bottom. These little lines right here, it's just called a break in the graph. They didn't want to start numbering at 0 and go all the way up to 33. So they kind of made a break in the graph, and we're just starting at 22, which makes sense in this data. Okay, at 1 month old, he was 22.5, so that should be right smack in the middle of 22 and 23. 2 months old, he's at 23.5. 3 months old, he's way up at 25 now, so he grew a little bit extra than he had the last couple months. At 4 months, he's at 26. At 5 months, he's at 27.5. So again, that was a little bit bigger of a jump this time. 6 months, he's at 28.5. 7 months, he's at 29.5. And that's all the data that we have. All right, so the next question says, describe the relationship displayed in the scatter plot. So one of the things that we didn't do that we need to do is we need to label this graph. So we could say that the x values, right? The x values was the age in months. So we can say age in months. And then the y values, we can just call that the length. And that length was measured in inches. So any y values is inches. All right, so we need to describe the data, and we've done this before. We always start with as the x values increase, right? So as we go further along the x values, or the x-axis, so we don't want to say x values, we want to say as the age in months of the alligator increases. Now, you could just say as the age of the alligator increases. We know that the table is in months. Okay, what happens to the y values? Well, first of all, it looks pretty close to a straight line. It's not exact. And what's happening to the y values? The y values are all going up. So we're going to say not the y values, we're going to say the length of the alligator because that's what the y values is talking about. And what do those y values do? They increase. And not only do they increase what we're going to call linearly, pretty much in a straight line. Now, there's another way to refer to this, is we could call this a positive linear relationship. Okay, so because it's the slope of this graph is going to be positive because the y values are going up, we would call this a positive linear relationship. All right, so the next question says, all right, now find the equation of best fit. So that means we're going to have to go to our Desmos calculator. We've got to go up to the 3 lines. You should guys be getting good at this by now. We've got to scroll down to statistics and linear regression. And the annoying part is we need to get rid of all of the data that is in the tables. Oops. So clear out the table. All right, so if your table is clear, now we need to type in the values. So the x values are the months, so those are easy to type in. It just goes 0 all the way up to 7. So 0, 1, 2, 3, 4, 5, 6, and 7. Don't go so fast that you make a mistake, but that's easy to type in. 1, 2, 3, 4, 5, 6, 7. Double check those. And then we got to make sure the y values go with the correct x value. So I can plug in 22.0, or you could just plug in 22. It doesn't matter. 22.5, though, we definitely need the 0.5. 23.5. 25.0 if you want. I missed the 0. Or just 25 works too. 26.0. 27.5. And then we've got 28.5 and 29.5. So we want to do a quick double check to make sure we didn't type in 2 instead of 22, but it looks like my numbers are okay. All right, so if I look at the graph up above, the weird thing is I can't see any points like we've seen in the past, but that's just because my points are too high, right? So if I move this down a little bit, now I can see those points because we got to look for a y value. All of our y values are in the 20s. So if we look down here, I can see where it's 0, 0 is, but I can't see the values because it started all the way up at 0, 25. And that looks like a pretty good line. All right, so we're going to scroll down to find our equation, and it says I want that equation rounded to 2 decimal places. So I know it's going to be y with the little hat on there, right? So we're going to start y with the little hat is equal to 1.1. Now, if I go 2 decimal places, I've got a 3 followed by a 6. So that's going to make it 1.14x plus 21.5, and it's an 8 with a 3, so that 8 is going to stay an 8. So y equals 1.14x plus 21.58. All right, now it says use the equation to predict the length of a baby alligator when he is 11 months old. So almost a year. So remember, 11 months is my x value. So I want to go y with the little hat, and we're going to go 1.14. Our x value is going to be 11 this time. And I want to add 21.58. All right, when I do that, I end up with a value of 34.12. Now it's asking for the length. We know the length is represented in inches, so make sure you put inches there. It's not 34 feet long. That would be a pretty big alligator. All right, and then the last question says, calculate the difference between the actual and the predicted. Remember, difference means subtraction. So I'm going to do actual minus predicted. Well, the actual alligator, it says in this problem, it says if the alligator was actually 42 inches long. So this alligator grew pretty big here. So my actual is 42. My predicted was only 34.12. So unfortunately, if I subtract those, we were off by 7.88 inches. So obviously, as he got above 7 months old, he grew pretty fast. Okay, and that data point, the actual was way above what we predicted. It was 7.88 inches above. All right, taking a look at our next example, it says Old Faithful is a geyser. If you don't know what a geyser is, it shoots water up in the air in Yellowstone National Park in Wyoming. For more than 100 years, Old Faithful has erupted every day at intervals of less than 2 hours, or 4 intervals of less than 2 hours. The data in the table suggests that the time between the eruptions may be related to the length of the eruption. And we are going to take a look at that on our calculators in a minute. All right, so our x values right here are going to be the length, and the y values are going to be the time. So we can label our graph right away. We can say the length of eruption, and that's in minutes. Okay, and then the y-axis is going to be the time until the next eruption. And that's going to be in minutes as well. I'm going to redo that. Now, notice that we didn't get any y values put on there. Okay, so we've got to do that ourselves. So if I look at the values, we've got anywhere from about 57 to 92. So I'd say like 50 to 100 would probably be a pretty good way to do that. Well, I'm going to put that little break in our graph. So I'm just going to kind of draw that break in the graph right there. And I'm going to start down here at 50, right? I could start at 55 if I wanted to, either way. And if I got to go up to 100, I'm going to see if this will work. So the next, I'm going to try to count by fives. So the next one would be 55, and then it would be 60, 65, 70, 75, 80, 85, 90. So the top would be 95, so I'm perfect. I only have to go to 92 there. Okay, could you count by tens? Absolutely, but then your data would be smushed together. All right, so let's go ahead and plot those points. So it says when the length is 2, the time of eruption is 57. Well, I'm kind of guessing here that's pretty much in the middle of 55 and 60, right? Because this would be 55 right here. So I'm going to put a dot there. Now at 2.5, well, 2.5 is in the middle here. I got to go up to 62, so I'm going to put a dot about right there. Next one is 3, 68, so that's up closer to 70, almost in the middle. 3.5 is, again, in the middle of 3 and 4, and I got to go up to 75, so that one should be exactly on the line. Next one is 4, 83, so that's up here a little bit lower than 85. And then the last one is 5, oh no, I got a 4.5, 89, so that's just below 90. And then the last one is 5, 92, which would be right about there. Okay, so again, they should be pretty close to the same as the points that I put on there. If you were up a little bit higher, but not quite to 90 for that 89, that's fine. They just got to be pretty close. All right, so the next question says, describe the relationship. Okay, so we have our little saying here. We say, as the x value increases. So we're going to say, well, what is the x value? Well, the x value was the length of the eruption. So we're going to say, as the length of the eruption increases. Okay, so what happens here? So as my x values get bigger, what happens to my y values? We're going to say the time until the next eruption also increases, right? Because it's going up. But not only does it increase, but if we look at that, it's not a perfect straight line, but it does kind of look like a line. So we are going to say linearly at the end. Okay, and again, we've used this before. It has a positive linear relationship, right? As the x's get bigger, so do the y's. So as x increases, y increases. That is a positive linear relationship. All right, so we're going to go to our calculators one more time. We should be getting pretty good at this, and we're going to plug in that data. Oops, get rid of those values. And we got to type them all in again. So we're going to go to the 3 lines up above. We're going to go down to stats, and we're going to press linear regression. Unfortunately, we got to clear out those tables yet again, so go ahead and delete those values as best as you can, or as quick as you can. I wish there was an easier way to do this, but unfortunately, I don't think there is. Oh, there we go. That wasn't too bad. All right, so we're going to go and we're going to type in those values to our table. Instead of 2.0, I'm just going to type in 2 because it's less numbers. But then we got to do 2.5, 3, 3.5, 4, 4.5, and then 5. If you did the 0.0, that's okay too. And then 2 goes with 57, then 62, 68, 75, 83, 89, and 92. So again, double check your values, make sure we got everything good, which I think we do. I can't see too much, although I do see part of the line, but the reason is if I just kind of squeeze in a little bit here, it's because my data is way up there. And again, it looks kind of like a straight line, although it's not perfect. But we do have our equation, and our equation's off to the side, and it says go 2 decimal places. So we get the y with the little hat is equal to 12.4. And then we got to look, after the 2 comes an 8, so that's going to be 12.43x. And then our y value, or y-intercept, is 31.6. So I'm going to go plus 31.6. There's a 4 after it, followed by a 2, so that's going to stay at 4. All right, now it says use the equation to predict the time until the next eruption. If the length of the eruption is 4.25 minutes, well, that represents an x value. So we're going to say x is equal to 4.25, and we're going to plug that into the equation. So we've got y hat equals 12.43. We're going to plug in 425 for x plus 3164. Plug that into our calculator, and we get 87.5. It would be 58, so I'll round to 2 decimal places because that's what we've been doing. Minutes. So that's how long it is till the next eruption if it's 4.25. And then the last one says calculate the difference between the actual and predicted. So again, we're going to go actual minus predicted. If when you visited Old Faithful over summer break, you saw a 4.25-minute eruption and the next eruption was 81 minutes later. So I'm going to go 81 and I'm going to subtract the actual, which we don't, or the predicted, I'm sorry, which is 87.58. That's what we figured out right here. Okay, so the actual was 81. The predicted is 87.58. So we're going to subtract those two, and technically we get negative 6.58. Now remember, the negative sign just tells us that it was below, right? Because our prediction was above what it actually was. Okay, and then that was calculated in minutes. So we're going to say 6.58 minutes. You can keep that negative sign in there, or you could just say the difference was 6.58 minutes. It was just, we predicted that it was going to be longer, and it was only 81 minutes. All right, so that is it for today.